We're going to be looking at alternator charging today. On our meter here, our alternator is running, and so we can verify that the alternator is running because we've got 14.5. Right, we start out with the battery being around 12.6 if it's a fully charged battery. Therefore, we should see the meter come up well above battery voltage, and you see that we are right now. I've got my red lead on the post that goes to the battery, and then I've got my black lead on ground, which the casing of the alternator is ground. And just because this is a Subaru won't make any difference. This is how it will be on other vehicles as well. I want to show you that, again, we're on DC voltage. We don't see the scale moving up and down. I'm going to turn it to AC voltage to make sure that our diodes are good. We want to have less than 0.4 of a volt of AC voltage. Oh, excellent, and we do. So we have 0.04. So if we had 0.4, then we have too much AC voltage. And again, what that means is that the diodes would be breaking down inside the alternator. If the diodes break down, and the diode's job is to change it from AC voltage to DC voltage. The more AC voltage that we have, less DC voltage that we have, and therefore we can't charge the battery as well. Now, one of the ways that we do this is that we are going to look at the charge wire on here. Now, one of the wires goes to the instrument panel, and it's the charge indicator light. One of the other fuses, in fact, two of the wires here go to the fuse panel, and the fuse panel, which is under here, one of them is the feed. Now, the feed is to provide 12 volts or something a little less than charging voltage. Let me put the charging voltage back again. So that way we have a feed to the rotor to tell the alternator to charge. So if you bring your attention over here, we see that we have a constant charge rate. Some vehicles will pulse width modulate. This one doesn't do that. Pulse width modulation would be where we see it moving in and out. Well, with this one, we see that we're at 13.65. That doesn't mean that we're undercharging. We're simply looking at the small wire that's on the alternator, and the small wire is what provides the charge to the rotor. The rotor is the rotating part, and it induces a charge in the stator, and we can see the stator here. Just these copper-colored wires that are just under the surface of the case of the alternator. So this is how we're checking charge, and it's working. If we're going to see full output, if we were looking at, say for instance, looking at how much amperage that we put out, we would use an amp clamp, and we put all the loads on. If you've got a VAT 40, of course you could provide the load yourself, and you bring up the RPM to around 2,000. That's where the alternator is the most efficient. So there you go. If all you've got is a meter, could you do this? The answer is yes.